Hello, everyone. Thank you for joining us today for our final webinar in our data series, using data to support work packaging with a 3D model. So before we begin, I'd like to share this timely safety moment on seasonal allergy tips and just a few helpful things to keep in mind as we approach spring are that you can stay indoors on dry, windy days. The best time to go outside is after a good rain, which helps clear pollen from the air. You can always delegate your outside chores to other people that could possibly stir up allergens for yourself. And then always remember to remove your clothes you've worn outside and shower to rinse off the pollen from your skin and hair. And then a few extra steps when pollen counts are high. Seasonal allergy signs and symptoms can flare up when there's a lot of pollen in the air. And these steps can help you reduce your exposure, such as check your local TV or radio station, your newspaper, internet, or whatever your local news outlet may be. And if high pollen counts are forecasted, start taking allergy medications before your symptoms start. And you can close doors and windows at night or any other time when pollen counts are high. And also just avoid outdoor activity in the early morning when pollen counts are highest. And you can also help yourself by keeping your indoor air clean. There's no miracle product that can eliminate all allergens from the air in your home, but you can use the air conditioning in your house and car. If you have forced air heating or air conditioning in your house, use high efficiency filters and follow regular maintenance schedules. You can also keep indoor air dry with a dehumidifier. Make sure you use a portable high efficiency particulate air HEPA filter in your bedroom. And clean floors often with a vacuum cleaner that has a HEPA filter. And you can also always try over-the-counter remedies. There's several types of non-prescription medications that can help ease all of your allergy symptoms. And finally, when that just won't work, you can always go see your doctor. So just some things to keep in mind this season. Okay, so today we're going to discuss how to consume 3D model data efficiently in work packaging. We're going to cover 3D model data to support work packaging, 3D model disciplines and on-build construction component concept, typing 3D model data, design data and fabrication data, typing component file, steel 3D model fabrication data, concrete 3D model data, concrete object tagging, non-modeled items, 3D model data exchange tips, and then if we have time, we'll get to some question and answers at the end. So these are some challenges in using 3D models as it is in the construction scope. We'll look at the main challenges, how to overcome them, and also which is the best way to eliminate the shortfalls to use them efficiently. And now I'd like to take a moment to introduce today's speaker, Justin Francis, O3's engineering subject matter expert. Justin has more than 2 decades of IT and engineering experience. He has a deep expertise in the oil and gas and BIM construction industry. He's the lead role in technical solutions for engineering data. He's also developed and deployed software and technical solutions for mega projects. And now I'd like to share a little bit about who O3 is. O3 is a modern web-based platform that leverages advanced work packaging and agile best practices to disrupt the status quo for companies in industrial construction who want to improve productivity, safety, quality, and predictability. With that, I will now turn it over to Justin. Thanks again for joining us today, Justin.
All right, thank you. Thank you, Tori. Thank you for the introduction. Hello, everyone. Welcome to today's webinar. More than a decade ago, I was working in the area of visual project controls using 3D models. In those days, it was an emerging technology. I remember that we waited for months to get the 3D model from our clients, negotiating with them, educating them, and trying to convince them about the need for 3D model with the data. It was very exciting when we got the 3D model. When I opened it, it looked good. Pipes were in the model, the elbows were in the model, and everything looked good. But when we select a pipe to see its properties, Instead of selecting a pipe, it would select a triangle. When I clicked on an equipment, it would select a rectangle 2D plane. Example, a valve was exported in 300 plus triangle instead of a single 3D object with its properties. I don't have to explain the rest of the story. It was a totally disappointing. We were back to square one again, convincing and coaxing the client into giving us the 3D model and data that were actually workable. Fortunately, we are not that situation anymore. We have traveled a long way from that time. We are much better at the data exchange now. Let's look at some of the benefits of using 3D models for work packaging. There are many benefits of using 3D model directly for work packaging. We can use 3D model data directly from the 3D model for construction scope. No need to export 3D model data to other formats such as Excel or CSV and then use the data in spreadsheet for planning or construction purpose. User can visualize the object that are going to be built and do visual inspection along with all its relevant data. 3D model can be linked with many other resources such as uh, drawings, bill of materials, documents, schedules, etc. All the relevant information needed for construction can be accessed through 3D model as an organized way. When we generate work packaging using 3D model, along with the packaging information, we can also include the screenshot of the 3D object as a visual documentation. Visual reporting like 3D model colorization based on the data such as status, constraints, approval, progress, etc. will be highly beneficial. These are some of the benefits. They are not all of them. There are much more. 3D models are created during design time and widely used for design verification, multidiscipline coordination, clash detection, visualization, and so on. We believe that the investment made in creating 3D model should not limit to the above scope, but extend to the construction phase as well. 3D model have many disciplines: piping, equipment, structural steel, electrical, instrumentation, concrete, HVAC, etc. Each discipline's objects are different. Purpose and method of construction are also different. Each discipline needs certain set of mandatory properties in order to use them for construction scope. Can we use the 3D model data as it is from the design software for work packaging? Well, it depends on what kind of data the 3D model has and how they are stored in the model. Also, equally important is what application we are using. Some information like a fabrication data will not be directly available in the design 3D model. So we should have a provision to update 3D model data with the fabrication information. In our experience, some disciplines like a piping, steel, equipment can be used without much enhancement to get the needed data for the work packaging scope if you are using the right tool. But other discipline, in some cases, can be a bit challenging. O3 On-Build provide a state-of-art solution to use 3D model and its data efficiently in work packaging. On-Build construction component framework is a highly flexible and dynamic framework. This feature will enable user to use 3D model data efficiently in work packaging. Framework is designed in a way that user can create construction components based on the data collected and conditioned from various sources such as 3D model data, fabrication data, calculated or derived based on other data. We can also import external data and include them to create a construction component enriched with all these data from various sources, but for the same purpose. Construction component is discipline specific. It can contain one or many 3D model objects. Same 3D model object could be used in different work packaging scope. So we allow the user to use same 3D object to create construction component for different work packaging scope. For example, 3D object used for fabrication work packaging can later be used for erection work packaging in different combination. Maybe in later stage, it can be used for test work packaging. For sure, construction component for this different scope will have different relevant data sets and graphical groupings. On-built construction component can be created even without 3D model data. Let's take a couple of examples. I will go through some details about piping, steel, concrete discipline, and 3D models data format and how to use in our work packaging. In piping, we can usually see two types of data, design data and fabrication data. When we use 3D model for work packaging, design data and fabrication data from the 3D model could be incorporated with the work packaging. Usually, design data will detail pipeline up to isometric level. When the purpose of the work packaging is fabrication, then the construction component can be created in isometric level with the needed fabrication information. You can see in the left side of the image, the construction component is isometric, which will be a single object in on-build, and the object will have property of isometric. Workface planner can select isometric and then add them to fabrication work packages. On-build will also store individual piping component property separately for each piping component of the isometric, so no data will be lost. When the scope changes and become erection, we need some more additional information. The reason is, in isometric, during the erection stage, many of its piping component will be grouped as a single unit in the fabrication shop. These grouped components called spools will be brought to site as a single unit for erection. So this additional information should be incorporated with the 3D model and in the design objects. Usually this information will be available through piping component file PCF. On-build construction component data model allow user to add additional information to the design object and then group them as the construction object and use them in the work packaging as available in the site. Definitely, these construction components seamlessly link to its bill of materials, drawings, specification, documents, etc. based on its purpose. In addition to that, resource status checking, constraints, execution tasks based on the construction purpose will be automatically wired to it. You can see in the right side of the image, the construction component is spool. Workface planner can select spools and add them to the installation work packages. O3 on-build has very advanced PCF processing algorithm. We calculate many additional information that are needed for construction or good to have for construction and add them to its spool level or piping fitting level. Following additional information will be calculated in spool level: inch dia, inch meter, spool, previous, next, connected component, example, a pipeline or an equipment, a spool or a field component, total length of the spool, number of welds, number of components. Bill of material will be available in each level, isometric or spool or piping component. Any additional information which are available as a design property could be included in the construction component at the relevant level. PCF geometry will be consumed from 3D model. Non-modeled items geometry will be created, example welds, gaskets, bolt set, etc. So all the geometry will be available in the 3D model. Connection components like welds will be consumed from PCF. Pipes will be physically broken as per the PCF spooling information. What I explained was in the spool level. O3 on-build allow user to check each pipe and pipe fittings properties individually if needed. Even after grouping them to construction component, example here, spool. This is only for the inspection purpose. In the component level, PCF Intelligent Reader will calculate length of each component, its previous and next component based on PCF data, and make it available for the user. Let's move to steel. Steel discipline is also similar to the piping discipline. In this example, I am talking about stick build erection scope. In steel design model, usually we get the data for steel members and plates, etc. For construction work packaging scope, especially for erection scope, we need 3D model data from the fabrication models. Design 3D object will be detailed in the detailing software like Tekla structures. In the detailing process, structural members that can be prefabricated in fab shop will be identified and grouped based on engineering details. This group called steel assemblies. Then unique identifier for the group will be assigned. For erection scope, this assembly will be a single unit in the construction site for erection. Steel fabrication model data will be read along with the assembly information to create steel construction components. Additional information such as total weight, length, etc. will be calculated and added to the steel construction component from the model data or as an imported data or as a calculated or derived data if it is not available in the assembly level. You can see in the picture that we can select an assembly in the 3D model. It will select all prefabricated members together. It can add it to a work packaging as a single unit. All relevant information for construction based on the scope will be linked with the construction objects. Example, erection drawings, bill of materials, even including the bolt list, documents, etc. When workplace planner add steel construction component to a installation work package, O3 on build will pull all relevant information, 3D model data, and its wired resources to the package. Many related activities could be automatically triggered, such as performing material coverage check, checking the status of the drawings and design, adding update constraints, adding execution tasks based on the work packaging purpose, and so on. The last discipline I will be discussing today is concrete. It is a bit different from the other disciplines. I will take an example of concrete foundation here. In order to use concrete efficiently in work packaging, the 3D concrete object should have certain mandatory properties. If you remember, in the beginning of this presentation, I throw a question. Can we use the 3D model data as it is from the design software for work packaging? And my answer was, in some disciplines, the object can be used as it is more easily than the other. In most cases like piping, steel equipment, the object from these disciplines are well organized and tagged. Equipment will have equipment name or tags. Pipe will have isometric name and tags or isometric names, and so on. In many cases, discipline like a concrete may not have this information in the 3D model. This is one of the reasons why we struggle a bit use concrete in work packaging. On-build concrete construction component needs some mandatory information like object tags. Objects should be modeled based on the construction sequence, very important. In many cases, we have seen that the concrete will be modeled without seeing its construction sequence. Let me take an example, the same foundation. Foundation has many parts like piles, pile caps, pedestals, grout, anchor bolts, etc. It is very common to see all these different construction objects graphically grouped as a single object in the 3D model. The single object will not match the construction sequence as it is not going to build in one phase. It is built in many phases. A single object in 3D model cannot store its data properly. This will make the 3D object of this discipline difficult to be used in work packaging. It is important to model a concrete object based on the construction sequence and tag the concrete object separately so we can link them to its relevant drawings, bill of materials, calculation, document like bar bending schedules, etc. I will give you an example of tagging or creating a unique identifier of a concrete object. Please note that the object tags are not GUID or CAD object IDs. They are the intelligent identifier of construction objects created during the 3D modeling. This is a concept of a construction tag. For example, in this construction tag 7A-14-CN-FN-21-PD-002, it has many information. Dashes are separators. 7A is the abbreviation of the plant, 14 is the abbreviation of the construction area, CN is the discipline or trade, FN is the abbreviation of the object type, 021 foundation type number. It could be from the engineering drawing or document, or we could create a type number for the same type of foundation. PD is the abbreviation of the object subtype. 002 is the sequence number. It can be used to create a unique identifier or group the same type of objects. For example, if you are using 001 and 002 for pedestals, then it will create a unique construction tag for each pedestal and construction components. In some cases, a wall is modeled with 2 or 3 graphical elements for modeling convenience, but these objects are going to be built as a single construction object. This object could have the same sequence number, so the concrete construction component will group this object as a single construction component for work packaging. It is very useful. Many companies might have their own procedure to create construction tag. The engineering tab can be directly used in 3D model if the needed information is available. Object can be tagged in detail or in high level, but very important, it should respect the how you are planning to build the how we are planning to construct the object. It should consider construction joints, expansion joints, concrete pouring, etc. Objects should be physically separated and tagged separately at these points. We have many years of experience in tagging construction objects. If you do not have a tagging procedure and need to use on-build for work packaging, we will be able to help you on this. O3 on-build construction component data model provide an option to link non-modeled construction object to its relevant modeled construction components. For example, linking cable tray system with a cable schedule. Once the link is established, then the workplace planner could create a work package for cable pulling using 3D model. In order to establish such linkage between 3D model object and non-modeled object, a common link should be available in both data sources. Before I closing this session, I can give you some tips for getting 3D model for work packaging, the things that we should be very careful about. Fix 3D model errors or missing info or export issue in the authoring tool. Internally, we use many techniques to model conditioning, but the best place to fix this problem is in the authoring tool. The reason being, if the model condition is done outside the authoring tool, then each time when we get a new revision, we should fix the issue again and again. This will be an additional work, and also fixed data will reside only outside the authoring tool. Use native model whenever possible. If you are using review models, avoid using multiple intermediate formats. When we transfer model from authoring tools to work packaging, it is always preferred to get the native models whenever possible. Otherwise, use minimum intermediate format, because using many formats may lead to lose geometry quality, its properties, grouping info, etc. For example, if you want to use fabrication model created in Tekla structure, then it is advised to get the model in IFC format. We do not prefer import first in SPD, then export its review format VUE, and then NWD format and use it. Get the model exported by project area discipline. This will help to analyze and use model efficiently, to check the mandatory attributes, and if needed, apply the model conditioning, etc. If the whole plant is exported in one model, it is good for other scope like status visualization, but not very efficient for work packaging scope. Export model specifically for work packaging scope, so the needed information will not be missed out. Avoid using models exported for other purposes for work packaging. When we export 3D model from authoring tool to construction scope, make sure that the needed information is included in the model. Otherwise, we will have a 3D model in the system without enough information. Also, avoid using the model exporter for other purpose for work packaging scope. For example, model exported for visualization or clash detection may not contain information about construction objects, but it might include wide area of the project. Save the export setting and use the same when exporting model with the revision. It is very important to save this export setting. Throughout the project, the model should be exported, use the same settings. When a model is revised, update only the revised model. This is highly important because in some project, there may be hundreds of models. Even certain intervals, the client will provide the whole project models, whether it has a revision or not. We should get only the revised model. Clear procedure for data transfer format, content, etc. for each discipline. Before starting the project, one should agree with the client, contractors, 3D modelers about the model data, format, model transfer procedures, etc. Let me summarize. We can use 3D model data for work packaging scope very efficiently with some preparations. Software like OnBuild provide very efficient data structure to consume, use, maintain, and manage data coming from 3D models. In addition to that, our OnBuild has a flexible construction component data structure that will accommodate external data to construction component and enrich the data used in work packaging. OnBuild supports many 3D formats. We use Autodesk Forge for model visualization. I would like to highlight some of the format we support through Autodesk Forge. SmartPlan 3D review formats, Aviva review formats, spooled PCF files, Autodesk Revit, and Bentley Open Building Designer native format with microstation tags, Bentley OpenPlan, AutoPlant, Integraph PDS and its data, CADWorks, Tekla structure we support through IFC, Naviswork, and many other formats like CATIA, CIS/2, Rhino, ProSteel, ArchiCAD, etc. We have a detailed data input specification requirement document for bringing 3D model and data to O3 system. Before starting any project, we agree with our clients on how we need the data, not only for 3D models, but also for the complete AWP implementation scope. This is very critical for successful implementation. All right, I hope you have enjoyed the presentation today. Now I will turn it over to Tori to moderate any questions they may have come in. Back to you, Tori.
Yeah, thank you, Justin. That was a great presentation with tons of great information. And thank you to some of the questions that you've submitted along the way. I believe Justin has answered many of them throughout the presentation. We've received some other questions directly through the chat feature. So we'll answer as many as we can get to in the time allotted, but please remember to reach out to us if we did not get to your question today. So first up, Justin, in a project, if 3D models are modeled in different authoring tools, can those be combined and use them together? If so, what about the different data structure?
A very good question. Yes, yes, we can use models that are modeled in different software in the same project. But a couple of things you should be very careful though. All the models should be modeled using the same coordinates. And second is the model should be modeled in the same location, orientation, and scale. This is very important, otherwise it will not match. About the second question, about the data, we have a strong mapping framework. We use rule-based mapping to create construction components. Even if the same property is stored in the different names in the model that are coming from the different authoring tools, we will be able to handle it without any issues.
Okay, thank you for that answer. One more question here. We've got, have you had any challenges with huge 3D models?
It's depend on many factors. We are using Autodesk Forge for graphical interface. The O3 on-build is a web-based platform, and none of our clients faced any issues with the loading limitation or performance in scope of creating work packaging. We recommend the purpose-based 3D model exported from the authoring tools that are exported by project area and disciplines, as I explained before. In that case, I can guarantee that you will not have any performance issue at all.
Okay. And I have time for just this last question here. How do you handle model revisions? Because the 3D model can be revised many times in the course of the project.
Yeah, it's a very good question. Well, when we get a new revised model, and if the component is missing in the revised model and it was a part of an IWP, we flag the package that is using the missed component through the work packaging grid. Also within the package, we flag individual components and corresponding execution task, and create constraints for the planner user, letting them know that the component is missing in the new revised model and they will need to address these changes.
Okay, some great answers, Justin. I think that's all the time we have for today. But just a reminder, if you've submitted a question inside the GoTo feature, Justin will reach out to you directly to be sure he's answered your question fully. And as a reminder, you can always contact us with any more questions at info@o3.solutions or online at www.o3.solutions. And we appreciate everyone's time today. And thanks again for attending, and please be on the lookout for next month's webinar on our website. We hope to see you again. Thanks.
Thank you.